Right. Any more questions? If not, maybe we'll move on to Rebecca telling us about how that's being applied in the Interstate Bridge Replacement Project.
Okay, thanks. Good morning, everyone. I'm Rebecca Frohning. I'm with the consulting firm WSP, working as part of the Interstate Bridge Replacement Program. So yes, I'm going to talk about how we've applied a lot of the concepts that Natalie just shared with the STIP process on this one specific project. So you're going to see a lot of the same information, but on more of the project specific level. So let me try to find my presentation to share. Okay, is it sharing?
We're seeing your notes screen. So maybe stop and reshare or something.
One moment.
That helps.
I just can't, there's so many pop-ups, I can't get to the buttons that I want to show. Let's see.
Becca, if you can get to the share screen button, there's a little up arrow next to it. I think if you select that, it will let you pick the screen you want to use.
Are you seeing the PowerPoint that's not in slideshow view?
Correct.
Okay. I just need to get to slideshow view.
Yeah, so that, yeah, that's what I would try. Right. What happens when you hit that?
Oh, here we go. Slideshow.
All right.
All right. Well,
maybe X out that little pop-up and go down to the lower right again.
this stuff always happens on like this technical meeting, right? It's just because all the Zoom stuff is in my way.
Well, if you don't have a lot of animation, we could stay in this screen and you can just go from slide to slide. Maybe put the up arrow, yeah, right there, so we can see a fuller screen. Yeah, that works.
Okay, do you see the full slide? Okay.
Yeah.
Okay, well, if you've forgotten already, my name's Rebecca Frohning. I'm here to talk about the project level greenhouse gas emissions analysis that we've been doing for the Interstate Bridge Replacement Program. And I'm going to give a brief introduction about the project, and I'm going to talk about the various components that we looked at the greenhouse gas emissions quantifications. Going to talk about the tools used that are a lot of the same tools that Natalie just mentioned, but I'm going to give a little bit more information about some of the challenges and limitations of using those tools on this project specific level. So if you're not familiar with the IBR, the Interstate Bridge Replacement Program, it's not just the bridge replacement. You can see from the graphic on the right here that it also includes variable rate tolling. There's light rail extension involved. There's improvements at 7 interchanges. There's improvements to some portions of the I-5 main line, and there is also active transportation components. So those are the main project elements that would impact greenhouse gas emissions once the project has been implemented. So as part of NEPA, the project has prepared a energy and greenhouse gas emissions technical report. So there's an air quality technical report, and the greenhouse gas emissions and energy are presented in a separate technical report. As part of this analysis, we look at the greenhouse gas emissions as well as the energy consumption due to the project. But for the rest of this presentation today, I'll just focus on greenhouse gas emissions. We looked at the emissions from, we looked at the existing conditions, a no-build alternative, the build alternative, which is being called the modified locally preferred alternative. And there are also some design options associated with that build alternative. For example, is the bridge going to be stacked or side by side? And some other, I think there's some other like interchange level design options. The future analysis here for this project was 2045 is what we were looking at. And the greenhouse gas emissions, like we've mentioned in the previous presentations today, we're not just looking at vehicle exhaust, we're looking at the whole life cycle. So also I should have included on here the fuel cycle that you've seen that involves the processing and transport of petroleum products, the upstream greenhouse gas emissions from electricity use, as well as the embodied carbon associated with the construction materials. So this table lists the tools that we use for these different components. For the construction, which is the first two bars here, these were evaluated using the FHWA ICE tool that I think Natalie just mentioned in the previous presentation. And then the level of detail required for these types of tools is pretty basic design information about the lane miles that are going to be improved, the miles of any sidewalk and path improvements, the lanes of any bridges and overpasses, as well as the track miles for light rail, number of stations, and number of parking spaces at any parking structures. So it's really just based on the project footprint. And then for the operations, we used the MOVES model for the vehicle exhaust, which is based on regional travel demand modeling. For the fuel cycle, which is the emissions associated with petroleum production, that was a manual calculation using the 0.27 EPA fuel cycle factor you saw previously. But for the upstream electricity use, we did a calculation similar to Natalie's, and I'll show these more in detail in future slides, but was also calling that the fuel cycle, considering electricity being the fuel for those electric vehicles. For operating the light rail and transit stations, there is upstream electricity use from those. And that we used a tool that you haven't seen yet today. FTA has a greenhouse gas estimator, which is very similar to the FHWA tool, also based on some just project footprint considerations, and then as well as the roadway and transit maintenance. And this is just routine maintenance, including landscaping, some routine like sealing a certain interval of repaving, just basic assumptions about general maintenance activities. So my next slides, I'm going to go into more details about these tools and what are some of the advantages of them, and how they can have some limitations when you're looking at a really specific project like IBR. So I mentioned the FHWA, the ICE tool, and the FTA tool. I'm going to talk about that. They're very similar. In fact, most features of the FTA tool are now included in the current versions of ICE. So you can see that just they're the same kind of planning level assumptions. This is, you know, early in the process. There's not detailed construction information involving exact vehicle types, exact phase scheduling, and those types of details. So what this tool does is it has assumptions based on a nationwide database of a variety of sources, from construction bid documents, data from state DOTs all over the country, other expert advice. So the advantage here is that you have a big pool of data to help find this kind of average activity associated with constructing your project. With minimal data needs, like I mentioned before, you don't have to have exact plans for what exact equipment and types and usage. We also don't need to know the exact construction materials, the material volumes. For example, you know, you're designing this big bridge, but you know, those exact material volumes, that's still under development. But with all of those advantages come some limitations that, you know, this is a nationwide database to pull from, but it doesn't include any sort of local regulations for construction standards as far as what kind of equipment can be used, what are fuel types, vehicle idling regulations. And for a state like Oregon that has some pretty forward-thinking regulations in this area, these aren't captured by the tool. The tool is likely an overestimate in terms of some of those underlying emission factors. Again, when it comes to electricity use, the tool does take into account you know, a certain degree of electric equipment, but that again is based on, you do get to specify your area, but it's still using default regional data for the Pacific Northwest. And the Pacific Northwest is actually a very large geographical region that goes through Idaho and into Montana, I believe. So again, those electricity, the electricity resources that contribute to the electricity are not going to have as much renewable sources as the Portland area does for this specific project. So that's another overestimate. The ICE tool does include calculations for bridges and overpasses, but it's really designed for overpasses and what you might think of an average bridge. And it specifically states that the calculations there don't apply to bridge structures over, I think it's 1,000 feet in length, or that are very high or carry a large amount of volume, which is definitely the case for the main bridge structure in this project. However, there are other overpasses and bridges that are included, you know, that it does apply to, but with the lack of any other resource, that is what was used. And, you know, now we have a case where we've underestimated the emissions from a project component. Another limitation is that there are some design options associated with the build scenario, but the level of detail that goes into this planning level tool just can't capture those changes. So if you read them on paper, you can tell that one option logically is going to include a lot more materials and probably a longer construction schedule, but there's not a way to really tell this tool to take that into account. So it's just more of a qualitative acknowledgement that this tool, you know, can't define that exact difference. So that was the main tool used for the construction emissions. For the operation emissions, we used the EPA moves version 3 model. So we talked about this in the previous presentation. So this is really unlike those planning level construction tools. Moves has the ability to really input a lot of data specific to your area, including your vehicle mix, your local fuel regulations, your local fuel formulation that varies throughout the country, your local climate, your local registered vehicles, any inspection maintenance testing. So it can be very specifically tailored to your region. And the other, probably, I think the coolest part about moves is that it accounts for phased in, it accounts for emissions and fuel economy regulations that are phased in over time. So when you're modeling a project in the future, it will adjust for the decrease in emissions that are due to these federal regulations. So I think that covered all of the advantages, and really the only limitation here is that, as Natalie described, Moves 3 does not include information about electric vehicles and regional fleet defaults. So that is something that we needed to address. And it also doesn't recognize, the model doesn't even recognize electric trucks as a source type. So you can delete the emissions from those types of sources if it's like an electric truck, the tailpipe emissions, but now you don't have any information about the power consumption that could be used to do some of those upstream electricity use calculations. The other limitation to moves is that the runs are time and labor intensive. So it doesn't lend itself well to doing a lot of what if scenarios. It really is a model that if you can either output emission rates once and then do some what if scenarios off model with those emission rates within, Excel or some other sort of programming, that would be your best place for doing so. That just trying to figure out how to make moves run for your electric vehicle situation within the model is really, it would be very time intensive. Natalie mentioned that Moves 4, it was just released in August 2023. It does have features that may help with a lot of these limitations regarding the treatment of electric vehicles. And it will hopefully EPA will be coming out with more guidance on how to approach electric vehicle use in the future. But at this point, we're still using moves 3 for this project, which is acceptable for purposes of NEPA. So we are still then having to face the challenge of making the adjustment for electric vehicles. So if you look at the table at the bottom of the slide, this looks a lot like the tables that Natalie showed in her presentation with the phasing in of the various vehicle types in that 2035 to 2050 time period. But you can just see a closer view here of what those exact percentages are. So I think, you know, the question is why do we need to adjust for electric vehicles? And you can see on the first bullet here, this project is really one of the first EIS projects that are considering the impacts of electric vehicles. Typically, a large scale project like this would do an air quality analysis, and air quality analyses are usually looked at as more of like a worst case condition to make sure that you don't exceed any set thresholds. But the greenhouse gas does not have any thresholds that we're looking at. So there's no advantage to looking at a worst case scenario to just prove that you're below some limit. We really wanted to try to capture something closer to reality, because the purposes of NEPA is to disclose the environmental impacts. And if we were going to talk about impacts that have 50% more electric vehicles than are expected, that's not a great representation. The other problem is that if we are looking at these larger worst case emissions, when we look at the impact of the project, it could potentially overstate the reductions due to the project because you're taking a percentage of a bigger piece. So I'll talk about that a little bit more on the next slide. So in order to accomplish this, we did some off-model adjustments, and these 3 bullet points look a lot like our previous presentation, that a set of emission rates was developed for the different vehicle type and fuel type combinations. Those 3 representative vehicle types you see in the table, and the fuel and the 5 fuel types you see in the table. And then created the full inventory based on this vehicle and fuel type distribution rather than the vehicle and fuel type distribution that is pre-loaded into moves. And then in addition to that, there is the manual calculation of the fuel cycle to represent the whole life cycle calculation. So we used for the vehicle emissions due to gas and diesel and CNG and ethanol, applied the FHWA fuel cycle factor, and for emissions from electric vehicles, applied a factor that was based on the miles per kilowatt hour, which is the electric vehicle equivalent to fuel economy, and the local carbon intensity. And again, that was a local Portland Metro value, not the whole Pacific Northwest average. Okay, so now in this slide, we're going to look at the results of the emissions analysis. Because this was newer and you know, we're all kind of learning this together, we went ahead and did the analysis both ways. We did the analysis as if without making any sort of adjustments for electric vehicles, just using the federal regulations for fuel economy that continue to be phased in over time and do show a decrease over time, as you can see in this kind of yellowish line here. And then we did another scenario where we did all of those electric vehicle adjustments. So what you see here is that, okay, so there's a couple different things to notice in this chart. This yellow and black, this yellow line with the black dashed area, this is with no EV assumptions added. So the yellow is actually the no build scenario, and the dashed line is with the IBR program implemented. And you can see on the scale of this chart, you can't see a difference. But there is a difference. It's a 0.28% difference. The emissions are reduced by 73 metric tons per day. And then in this other blue dashed line, it's similar. The blue is the no build scenario, but now we've added those EV assumptions that would take place in the region, whether or not the project was built. And then the dashed line on top of that is the build scenario that also includes those same EV adjustments. So again, it is a change that you can't see very well because we're talking about the whole 4-county Portland metro region here. The emissions are reduced by 45 metric tons per day. So it's a 0.25% reduction. So there's two things I want to point out. So I mentioned before, if we did not take the EV assumptions, if we did not include EV assumptions, we've now overstated the decrease. It's, you know, I'm sure in the scale of numbers that we're talking about, you know, 73 versus 45 isn't a big difference, but in the context of NEPA, where there's a lot of scrutiny from a lot of different agencies and the public, you definitely don't want to look as though you are making the project look more beneficial than it is, and just being very honest and disclosing the best available information. The other thing I want to point out, again, in the context of this NEPA document, if you look at the graph on the left, you think, well, this project has like no change. But when we are considering all of these changes due to the Oregon's electric vehicle mandates, we get to kind of talk about how just those alone, this gap here is over 8,000 metric tons per day difference. So that's going to happen whether the project happens or not. But then we're also showing that the project doesn't interfere with that anyway. And if anything, it supports this reduction, and it supports the state's goals to continue reducing greenhouse gases. Let me move my window so I can make sure I saw everything that's over here on the right that I wanted to talk about. So the actual interstate, the actual technical report included with the NEPA document, it shows both of these scenarios to, again, like disclose that this is an ongoing area of research, to show why it's important to understand that there is a lot going on despite the project. And I think this is also, I thought about this graph when we had the question about, you know, what are your assumptions in the EV fleet after 2035? And again, we want to be careful not to overstate this reduction as well. It could be a bigger reduction than this, or it might not. And the NEPA technical report does talk about a lot of these uncertainties and how they could affect the numbers that are presented within the document. So everything here, this was all in the greenhouse gas and energy technical report. But there was an additional technical report prepared called the climate technical report. Natalie mentioned that there are new CEQ guidelines as of earlier this year that require EIS projects like this one to not only quantify and present the greenhouse gas emissions, but also describe the climate impacts, contextualize those emissions, and just provide a lot more information to the reader. We saw a lot of numbers today in talking about like million metric tons of greenhouse gas emissions. And I mean, that's just not a number that any of us can really wrap our head around. So I think that a big purpose of that new CEQ guidance is to encourage projects in regions that may have not already been looking at greenhouse gases to start doing that. Oregon is definitely ahead in this area. There are other states that are just now taking their first look at considering greenhouse gases for transportation projects, and also provide that context. So we accomplished this in the IBR program by providing a separate technical report, because the greenhouse gas and energy report is loaded with so much technical information, all of the documentation for much more than what we've shared with you in the presentations today. There's a lot of tables, a lot of sources cited, and it really can get hard to read if you are a member of the public and you want to really understand the context. So we developed this separate report. It builds on all of the calculations that were presented as part of the energy greenhouse gas report. So it repeats some of the conclusions without going through all of the background data. And these bullet points here reference specific requirements or guidance bullet points within that CEQ guidance on how to address the climate impacts, including talking about more discussion on mitigation measures, like I said, providing additional context, incorporating environmental justice considerations, and talk about resiliency and how the project can be resilient to climate change. And the team, so in addition to just meeting the NEPA requirements, the team also took this opportunity to provide more context about how the project has considered climate throughout the planning and design process. So it was a place to really focus on some of the working group activities that have started early throughout the project planning process. It's a place to show how a lot of the project elements are consistent with other goals, policies, and plans in the state and locally. For example, when we're talking about metric tons of CO2, honestly, some of the active transportation projects, you don't see them on that scale. But this is a place where we could really talk about how there's all of these project components with the overall goal to reduce emissions, and talk about how those elements were included to help meet those goals. This is also an opportunity to talk about some of those construction limitations in the construction emissions that we talked about earlier, that those construction emissions are based on a lot of national averages. So this report provided a place to talk about a lot of the considerations that are being made in planning the design and the construction processes for the project, that may not necessarily be a commitment, that are included in calculations to make the calculations true, but to talk about the ongoing work that will still continue as the project moves forward. So that is the end of what I wanted to share about the project today. So I'm going to try to see if I can do a better job at technology to stop sharing and see if there are any questions about the project analysis. So this is a supplemental EIS. I think it's not yet released to the public, so it's still undergoing various review cycles, but it will be coming, I believe, in early 2024.
All right, thank you so much, Rebecca. That's just a massive project, and getting all those details all the way down to the transit level that we hadn't talked about before. I think it's exciting. This is the first time I've ever seen people like address the greenhouse gas at this level with like just the recently passed Oregon regulations, and the fact that you are showing, you know, and I go back to that chart where I had the two lines where the build versus no build is this like 1/4% or 1/3% change in either case. And it's a little bit smaller if we assume that the fleet electrifies, because we won't have as many combustion engines, and they're the ones that would save emissions in those out years from congestion, but we won't have as many of those. So it's a slightly reduced impact, but still very close to what you got without that. And we just didn't know what that answer was until we did that analysis. And I don't think anybody in the US has really kind of done that kind of comparison. The other thing I think that jumps out when you start to look at the true electrification of the fleet is that trucks are, you know, 3 times the emission rates of passenger vehicles, and they're just not, you know, moving to electrification or hydrogen as fast as others. So that's the other thing, is when you start to break it down by vehicle type, you might do some different treatments to keep that greenhouse gas number down, which would be maybe focused more on whether it's tolling of the freight vehicles or some more accommodation to keep their emissions down. So really exciting that you're doing this. Looks like we have a question here from Li-Ming Wang at PSU.
Great. Thanks for a information-packed presentation there. My question is probably less about the emission, but more a technical aspect. I haven't got a sense of to what extent you include the so-called induced demand because of the IBR. So can you talk maybe a bit about to what extent you incorporate induced demand of travel because of the new bridge, right? So potentially there are people moving, relocating business, household relocating. If we kind of make crossing Washington and Oregon, crossing the Columbia River a bit easier, the travel time more predictable, faster, and that would have an impact on greenhouse gas emission. That's what generally labeled as induced demand. Have you considered that part? And then to what extent you can talk about that? Appreciate it.
This is a very popular topic, and I admit that I'm not a travel demand modeler, so I don't know all of the details about that. I will say that For the air quality analysis, we do use the output from the regional travel demand model. And, you know, to whatever extent that modeling accounts for any sort of induced demand. But I can't, I don't know the details about that to be able to answer your question about that today. It is addressed in the transportation technical report that is included as part of the SCIS. So that's where I would go for, you know, details about that for the project. But I can't say that I know enough about that to really give any more information than that.
Okay, that's fine. Thank you.
From a non-official source, you know, it is the regional model, so it is getting some route switching and so forth, right? But I think you were also mentioning sort of the land use change. And my understanding is that there were Metroscope model runs that were done in the previous Columbia River crossing. And Rebecca, I don't know for sure, but I thought that those were mentioned in some of the project documents you have. I don't know if I don't think there's been new analysis as of this writing, but anyway, just a couple other thoughts on that topic. Any other questions? I wanted to clarify a little bit. I think, you know, this came up with, we were talking with Eric Hess from PBOT there about the 2035 assumption and how that was held. I think there's some, you know, gray area in terms of our fully understanding of what's going to happen in 2035 or 2040. I feel like what was in some of the emission rates that were used are really sort of somewhat optimistic in 2035, because there are some credits that are allowed in there that manufacturers could sell less EVs if they do other things. And also not all vehicles would be purchased here in Oregon, and that's particularly true for freight vehicles that are coming through. So I think there's some gray area in there. So our, you know, holding that 2035 volume is probably still a pretty good marker at this point for our best guess. So I don't think that that's that far off or that bad of an assumption at this point. And the other thing that you had mentioned, Rebecca, was moves 4, right? So you're still using moves 3. Moves 4, I think, might be part of the RTP sort of in Metro. I think they're shooting to use the moves 4. So that would be the first time we'd use it in the state. It is supposed to beef up this idea of electric vehicles and have that national look, you know, now that the, you know, IRA and IIJA, those funding programs at the federal level are really like moving us towards that electrified future. So it will have the national, but it won't have Oregon's, right? So we're going to continue to have that sort of Oregon increment that our regulations are a little bit more ambitious than the state. So continuing to be a challenge, but should help us to actually start to quantify that in a little better way. All right, well, if there's not more questions.
Question from Eric in the chat.
Oh, there is. Okay, let's see. Eric, if you want to chime in, or I can paraphrase. There you go.
Yeah, perhaps less a question than a comment on that, because my understanding, based on our previous review of some of the technical reports, was that it was indicated that land use changes were outside of that. Though I appreciate Li-Ming's question, because we're wondering if such a significant project and improvement in such a bottlenecked area would really not induce land use changes, which we found dubious. But I believe that was not the intent, and I don't believe that it was changed in response to those comments earlier in the process. So, for what it's worth, not that this needs to be the space to hash all that out, but just while it came up.
Appreciate it. Thanks, Eric.
I told you it was a popular topic.
Indeed, Rebecca. So, I appreciate the point that was not your focus. So, yeah.
And it looks like Matt's chiming in here on induced vehicle demand triggered by RBI. Added vehicle capacity is offset by tolling and transit improvements. Right. So I don't know, Rebecca, you could probably tell us the number of additional lane miles that are being added, but those would be offset by some of, you know, the tolling obviously is certainly a way to manage demand, as is providing those quality alternatives in the transit improvements.
I will point out that this is something that we attempted to do within the air quality and the greenhouse gas and the climate report is to talk more about some of these small incremental changes, and that even though we're only seeing, or like you're only seeing it in the report tables, like a total VMT, and everything works together. So we tried to do a better job than in previous projects about, addressing all of these incremental pieces, even though we can't itemize the impact of each one. So, discussions like these have helped, really make these discussions more valuable, and not just, putting all of the numbers in a table, but, providing as much context to the reader as possible.
Great. Chris, did you want to chime in here or have another question?
It was more of a chime in about sort of the Metroscope topic, and I don't want to belabor the point all that much, but I think we looked at the sensitivity of Metroscope within the context of the value pricing feasibility work, and didn't see a lot of sensitivity of Metroscope to sort of, some of these big picture changes that we're talking about in the context of the IBR. I'll also point out, it was before my time, but I'm pretty sure that some work was done in the previous iteration of the bridge work with Metroscope and trying to understand any sensitivities, of that the model would have in terms of land use changes resulting from, from bridge capacity and travel time decreases and that sort of thing. So, and I want to say that the outcome of that work was, I think didn't sort of jive with a lot of folks' expectation. It may have more to do with Metroscope, frankly, than sort of, than sort of some of the assumptions were and some of the expectations we're talking about today. And so I'll muddy the water a little bit more by those comments. And so.
Yeah, I guess I just would, back up and say, what are the best practices to try to manage latent and induced demand, right? If you go on the top thing, it's tolling, and that's what we're trying to do. Right. And it's providing quality alternatives, and that's what we're trying to do. If our technical tools are not able to get to all this stuff, I guess the third thing I would say is manage land use. And we have pretty tight land use laws in Oregon, as well as Washington, but, watching your land use and the zoning changes that happen. So which is a little hard for the project itself to do because those are local actions. But, as the public cares about this, I think we're not going to meet our greenhouse gas goals without tolling. We're not going to meet them without putting quality, alternatives to driving out there. And watching the land use changes that occur and keeping to our land use laws. So at the end of the day, analysis can only take us so far, and we need to continue to push on having those ingredients in all of our projects that have high potential for latent and induced demand. Eric, you want to chime in as well?
That was just, like Matt said, good point, right? The tools need to, lift up the policy and other conversations so they don't resolve it. But yeah, so anyway, appreciate the discussion. That was just a coming on thumbs up kind of things. I couldn't do it in the chat when you're talking for you.
Sounds great. I mean, it's a super important thing. This is a big project, but we are trying to, have interstate facilities here and as particularly keep that freight moving, but also encourage people that have, more flexibility to move across the region with the transit options that are really, beefing up in quality through the project. And avoid those tolls.
Thanks. Maybe I will just note, right, like really appreciating how much more sophisticated we are getting on like the speed and the construction and other measures here. But I think we know from including the IBR analysis itself how significant the use phase is. I think that's why some of us have been so concerned about the analytics around induced demand, because that can make pretty big difference potentially in what the actual impact is. So I think that's why this is a real topic area, and one that I know we've had discussions in past with Metro around sort of state of the practice and whether we're doing everything we can in that space. So not to dive too deep there, maybe future conversations with OMUG or others. So just putting those pieces together, because in the end, if we are not inducing demand, that's a lot easier to get there, given the rapidity of change we need. So, right, there's concern about pushing in the other direction, even though there are obviously a number of benefits to the project, and a lot of requirement around the seismic and all the other improvements. So anyway, appreciate the complexity of the conversation. So just
yeah, and we absolutely won't get any of the goals, greenhouse gas or congestion relief, if we don't actually manage the latent and induced demand questions. So yep,
exactly.
important.
Nice.
Keep our feet to the fire.